Good afternoon, everybody, and welcome to another Netflix seminar. So today's speaker is Victor Brabant from of Lyon, and he's going to talk about applying modularity to temporal networks modeled as linked streams. And for the discussion part, he will talk about managing PhD and industrial. So whenever you want, the floor is yours.
Okay, thank you. I'm very happy to be here and to present my work. So I'm going to talk about how can we adapt modularity to temporal networks modeled as link streams. So why is this topic? Why did I choose this topic? Oh, sorry, yes, and I'm a PhD student at the University of Lyon 1, and I'm a part-time working in a company also. So we will, I think, discuss about that in the second time of the interview. So why did I choose this topic of generalizing modularity to temporal networks? It is because communities are a very interesting topic in the network science, and most of real world networks are temporal networks, and there is no a very fine way to model them as with the perfect temporal accuracy. So we need to model them with link stream, and there is no satisfying community detection method yet, in my opinion, on link streams. So we choose to take like the most common, the most famous one on static networks, which is based on the modularity function, and we choose to generalize it to link streams, or at least we try. So okay, so you see my second screen now. Yes, is it okay?
Yes.
Yes.
So the most common thing to do when we want to talk about temporal networks is to take like snapshot sequences when you have slowly evolving networks, like when edges doesn't change very much. You can just take a sequence of static um, networks and work with that, and there is a lot of literature about how to treat this kind of modelization, but it is not very suitable for if you have fast interactional data. For example, if you want to be very, very precise about when an event occurs, an event would be an interaction between node U and V. So we prefer to talk about link streams. So what you see on the screen is an illustration of a link stream. So the horizontal blue lines are the nodes. So you have nodes, and the vertical dashed light blue lines are interactions, and you have the time from the left to the right. So you can observe interactions between two nodes at any time, at or specific time. And this is how we define the link stream. So we need a time interval, a set of nodes, and a set of events, or we prefer to talk about interactions. And this way we have perfect temporal precision. But the problem is that this kind of modelization, there is not there is not a lot of tools to manipulate this kind of representation. It started like we can generalize the concept of shortest path or connectivity or things like that. But it's still, the work is still going on, and there is no quality function for community structures on such a representation. So that's why we want to generalize modularity to that. So I will first talk about the modularity, try to introduce it again. Like I said, it's a very, very famous formula for to qualify the quality of community structures on static networks. So basically, it is the difference between the number of edges you have inside communities and the expected number of the edges. And the expected number is always it always depends of null model. Null model is a naive random generation, a naive random model that could have generated the graph that we observe. For example, the most common null model is called the configuration null model, and it says that the graph you observe is generated according to the probability that is given by the 2 degrees between two nodes. So the higher two nodes will have a degree, the biggest the expectation of a link between them will be. And so the most common modularity function is here on the screen. You can choose, you can change it to choose the null model that you prefer. You can adapt it to bipartite graphs. You can adapt it to directed graph. I mean, you can do a lot of things from that. So this is part of why we choose to generalize the modularity, is because once you have this simple formula, you can easily adapt it to a very to a lot of different network structures. So we are not the first to be interested to generalize modularity to temporal networks. I think the most interesting result is what we call the multi-slice modularity, but it is based on snapshot sequences, as I show you earlier. So you have to model your data with like you expect your temporal networks to be very consistent at any time that you observe it. If you consider a link stream like I showed before, it is very probable that at any time you will only have one edge, one interaction in the network. So you cannot model your data like that. And you cannot use the multi-slice modularity on it. Yet, it is still an interesting function. And you can see that the multi-slice modularity actually is the sum of the modularity of each snapshot with a null model for each snapshot, plus a null model which is based on artificial edges built between node instances of each snapshot. So it gives the formula that we have here. It's not exactly like I said, you have to renormalize some things, etc. But basically, it's what I said. And the problem with that is that you have to define the weight of the interslice weight edges between two nodes instances. So it it's it makes you it's kind of arbitrary, you know. So you cannot take that formula and use it to judge two different community structure on the same temporal networks modeled as a snapshot if you change the temporal edges weights. So this is why we can say that it is not exactly a quality function, in my opinion. But still, we look at it and we choose to reinterpret it in a formula that we call the abstract modularity. So the abstract modularity is now the number of edges minus the expected number of edges, just like before. But now we add a smoothness term. And the smoothness term in the multi-slice modularity is the term that is dependent on that depends on the interslice edges. So now we want to adapt this abstract modularity for link streams. So it means that we need to find a null model. for the expectation part. And we also need to find a smoothness term. So that's the challenge now. So spoiler alert, it's not that easy to find a null model on temporal networks, on link stream especially. So what we propose is the longitudinal expectation. So it is made of two terms. We propose three versions of it. So the co-membership, the joint membership, and the mean membership. So each of the three is made of the product of two terms. The one is the first one is the expectation term if the network would have been flattened in a static one. And the second term is the time weighting term according to the size of the communities or to the duration nodes spent in the communities. So the first one, the co-membership expectation, is, in my opinion, the more intuitive one. It is very similar to the multi-slice modularity as we observed before. And it corresponds to the idea that you can only expect interactions between two nodes if they exist in the same time in the same community. But it raises some issues that I will present in the next slide. So we present two more longitudinal expectations. The second one, the joint membership expectation, depends on the size, on the duration of the community. So it will favor, like I say, rectangular communities where all nodes start to belong to the same community together, and they cease to belong to the same community together. But it can seem a bit restrictive to conceive communities, temporal communities like that. So we propose a third expectation, and the third expectation is based on the geometric mean of the two node duration inside the community. And it is a compromise between the two others. So why we don't like the first one is because of this. If we have this, for example, what we call topochron disconnections, here we have twice the same link stream, but with two different community structures. Communities being represented by the different colors. So if we take the co-membership expectation, we will have the same score, the same modularity score on the two community structures. But intuitively, we would like to say that the community structure A would be better than the B because you have a separated sublink streams that you want to put in separated communities. So this is why we have two more expectations. Now about the smoothness, if we don't add a smoothness term, like we don't have one by now, the two link streams, the two community structures on the link streams will have the same score because the formula we propose, I mean, counting the number of edges inside community and the expectation will only, it's the same as if we count time by time. So we need to introduce a proper smoothness term. This is our smoothness term. So we introduce the notion of community switch count, which is a number of community changes for a node. For example, if you look on the right, you have two communities in blue and red, and for example, E leaves the red community, then enters it again, so it changed community 1. So we say that eta E is 1. Eta D and C are 0 because they always stay in the same community. Eta A and eta B, they leave the red community to enter the blue community, then leave the blue community to enter the red community. So we say that they change twice community. So their community switch count will be 2. So we do the sum of, we compute the sum of each community switch count. And we have a weight parameter omega that allows us to tune the smoothness term. For example, if we want to have communities very continuous, we can set up a higher weight parameter. And if we want communities, if we want to allow communities to be less continuous, we can choose a lower weight parameter, omega. So the point with this approach is that it does not depend on interslice edges, and that was the difficulty about the multi-slice modularity. So now we have 3 expectation terms and a smoothness term that work on link streams. Okay, an example on the smoothness term. If we have this trivial case, so if you remember the expectation formula, they all depend on the community's duration and on the node lifetime inside communities. So if we reduce community's duration on a very short time around each interaction, we will minimize the expectation term, but keeping the same first term. So we will it will leads us to a modularity of almost 1 or something like that, which is something we don't want, because it would the result would be something like we show on the slide. So in this case, if we take the smoothness term that I introduced in the previous slide, we can see that the smoothness term will be equal to omega approximately. So in this case, the modularity with any expectation term and with this smoothness term will be approximately equal to 1 minus omega in this case. So we can see that the smoothness term is here to favor communities that will be continuous, and also to prevent such a trivial case, because you know in the modularity, in the static case, the modularity is kind of built to avoid trivial cases, such as putting all the edges inside the same community. So in the temporal case, the temporal networks also raises trivial cases we have to look after. So now we have 2 longitudinal modularity expressions that are here. They are a bit complex maybe, but with beautiful colors. So in blue, it is still the number of expectation between nodes U and V in community C. In green, it is the expectation of the number of interactions between community nodes U and V inside community C. And in orange, you have the smoothness term that I just talked before. And there is something, the next property that I would like to introduce now, because the 2 formula that I introduced in the previous slide are kind of independent to any time aggregation. Because something I forgot to tell you earlier is that if you have a link stream in the real life, you don't have a lot of tools, as I said, to manipulate it. So you will want to aggregate data around time window. So you have snapshot sequences. So, and now you can work with that. But the drawback, if you do that, is that first you have to choose the size of the window, which is can be an arbitrary choice. You will lose temporal dynamics within the time window, and you may introduce some artifacts at the borders between snapshots, because you will introduce maybe hard changes. Here is an example of, we have one link stream, the one on the top left. This is the pure one with a delta time of 1. And you have 5 nodes and 2 communities in blue and red. Now, if you take the second link stream, with you aggregate data on a window size of 2, you have this with the same community structure. And now, if you aggregate data on a window size of 8, you will have the snapshot sequences of size 2 on the right. And the point is that with any of these 3 configurations, the formula result will be the same. So it's not very common when you manipulate temporal networks to have this kind of results about when you manipulate temporal networks and community structures. So yes, but of course, if you take the one on the top left, maybe you can find a community structure that is more suitable for this granularity. So we have to keep this in mind. Okay, so now I want to talk about, I want to show you some experimental results. So we took the socio-pattern high school interactions, which is, if I remember correctly, interactions between students in high school in France during 5 days. So you have an interaction every 20 seconds if 2 students are close together. And there is one thing we know is the classes of the students. So if you look on the one on the right, so if I remember, maybe we have like 200 students or something like that. So we don't represent ages, time interactions on this. It would have been way too hard to understand, to read it. So if you look at the graph on the top right, you have the classes as communities, and the both longitudinal modularity scores are the same. The vertical black lines are the nights. So at the night, in the night, there is no interactions, and so the communities cease to exist. I didn't display the whole night because it would have been absurd, but keep that in mind. So what we did is that we try different combination of the multi-slice modularity to find communities. So we vary the window size of aggregation and the interslice weight. And we saw which community structure was the best for both longitudinal modularity formula that we have. And we did the same with another community detection method, what we call the no smoothing method, which is again taking snapshots, aggregating data into snapshots, and applying static modularity, static Louvain on each snapshot, and then merging communities from snapshot to snapshot according to the Jacquard index of each pair of community. So this is what the best communities look like on the bottom of the slide. So on the left, it is the best community structure according to the mean membership modularity. And it is given by the multi-slice modularity method And if I remember correctly, it is returned with a granularity of something like 5 minutes, so the finest one we had, and a nice, I mean, a relatively low interslice weight. But the best community, according to the joint membership, is the one on the right, which is given by the no smoothing method. And there is a lot of community here. Okay, forgot to say that on the left, the white things are there are communities on the white things, but I choose not to show it because I mean I displayed only the top 12 communities, so it's still understandable. And on the right, I displayed all the communities, so we can realize there is like I something like 100 communities, but because sometimes you have only one node in its own community, and as we can see, it indeed this formula indeed favors rectangular communities. I mean, rectangular is not very scientific, but it's simpler to say it like that. I like this term. And that's all for now. This is the paper that we are that is being reviewed right now. And there is an archive preprints that you can find with the QR code on the left, and some code if you want to have fun with it, with the QR code on the bottom right. So the next step, because now we have just a few words for the next step. Now we have a formula that can tell us if community structure is nice or no. And now we have to find our Louvain algorithm to optimize this formula and automatically find the best community structure for this for the functions. That's all for me.
Thank you, Victor. Does someone have some question on this? I can start maybe. Okay. So I missed a part that is which is the trivial case in which the modularity should be one.
Sorry, I don't understand what you say. You have some drop, I think.
I mean, which is the trivial case in which the modularity should be one? I missed a part. Sorry.
Can you repeat? Sorry.
You cannot hear me?
Yes, a
I
bit.
can.
I
But
can say it for
yeah,
Lisa.
let's try like that.
She wants to know about the trivial case
Okay.
where the modularity is equal to 1, if I remember correctly, but it might be wrong. Yeah, she wanted some explanation because she missed this part.
Okay. Yes. So, yeah. First, what I forgot to say is that we decided to consider community structures that are the most general possible. So we allow nodes to have nights, communities to have nights, so to not belong to any community. So that's why we can have this kind of representation, this kind of community structure. So to better explain it, I need to find this, or maybe this would be better. So if you see in the green term, we have the time. For example, you have the duration, the community duration on the joint membership, the first equation. So if you reduce the time a node spend in the community, you will this term will tend to 0. But the blue term will remain the same. So the penalization term of the expectation will be reduced to nothing. So the blue term will be maximum, and so it will be in our example equal to 2m if we put every node in the same community only when they interact together, and 2m, and so we will have a 2m on 2m will be equal to 1. It's not exactly equal, but it will tend to 0, to 1, sorry.
Okay. Clear. Maybe last question. I don't know if you can hear me okay now. More or less. Maybe I can write it in the chat. Or maybe I try just saying it. Because yeah. Anyway, my question is like, now this modularity measure is a static measure. Okay, so it gives you information on on the community during time. So it's not like a temporal measure. What about a modularity that changed over time? So it tells you how the community changed. Of course, you will have to do an aggregation of snapshot of, yeah. But what about the option?
Yeah, but I think that modularity that will evolve through time. I mean, the question is always the same for me, I guess, because how do you choose your granularity? Because if you consider this time of representation, what would be the modularity when there is no interactions? And I guess modularity, well, it's a very famous formula, but it also has a lot of drawbacks, and including especially when the networks is a bit degenerated. So I'm afraid that if you have a temporal modularity, a modularity that evolves through time, you will be way too dependent to the degeneration, to the temporal degeneration of the temporal network. I don't know if I understand your question.
Yeah. Thanks. So anybody else other question on this part? We can switch to the discussion part then.
Okay.
Do you have slides or?
Just one. Oh yeah, I forgot about this one. It's okay. It was about the experimentation, when you vary the interslice weight ratio, the window aggregation, etc. But it's in the paper that that's here. Okay, so I just take a few notes. So yeah, I work in part-time in a company. So it can be an interesting question. I don't know. I don't know a lot of people that do some complex network PhD that work in a company. I mean, it's common. I have friends who do that, but they do like deep learning or stuff like that. But I don't know anyone who does that with complex networks. And yeah, it's very interesting. And it's frustrating also because I feel like I don't have all the time I want to deeply investigate some topics that I would like to do. I feel like when I'm reading too much papers, I'm wasting my time because everyone in the company they don't read papers, they work. I mean, you have this kind of social comparison. It's also nice but it's nice because it allows you to change topics, and I really like it. So when you come back to your PhD topic, I mean, you have some new ideas, you have some fresh ideas, and it's very nice. It also gives me new ideas on the traditional work. So it's nice also, I guess. But it can be difficult. I mean, when we think about the time management, officially I work 3 days a week for the PhD and 2 days a week for the classic work. But in reality, I don't do that. It's like I'm lucky because they let me choose how to manage my time. But I think it's not always like that. And I have friends that failed their PhD in company because of that, because of managers that did not understand what doing a PhD means, and I think it could be difficult. I'm very lucky. I feel like I'm lucky to be where I am and working on the topics that I'm working on. So
Can I ask in between, what can you talk a little bit about what is your focus in the PhD and what is what you're working on in the company? And if you have to, like, what are the connections between your two topics, and how was it, like, how did you, can you talk about how this emerged? Like, who was interested in whom? Do they collaborate together, like the people you work with academically and from the company, so we understand better?
okay, so my PhD work is I started like a bit more than a year ago, and my topic is what I presented you. So now the next step would be to find heuristics to find dynamic communities, and then to apply it to multiple kind of data. And the company I work with, Sahar, they are interested in open source data. So you have data that is not very clean, that you have to manage with. It's not easy data to manipulate. So it's the same difficulty for every company that does that, I guess. But they choose to put the focus on the temporal aspect on it, and I don't think there is a lot of company that does that. So this is why we started to work together on that. And I mean, to be a bit more concrete on what I work beside my PhD. For the company, I mostly work on cryptocurrencies, Bitcoin, so analyzes transactions or things like that. So it's related to complex systems. It's related to temporal networks. But you have it's very specific. It's way more concrete, because what I just presented you is a bit abstract. I really love abstract stuff. I come from math, so I'm very happy to do that. But yeah, I'm really happy to do this abstract thing, and it's something more concrete about the Bitcoin analysis. So yeah, that.
Very cool, thank you. Can I ask also, the people, if people have questions, please chime in. Oh, sorry, Sylvia, I see already. Can you talk about if there are safety measures from any or both of the sides to make sure that you don't invest too much into one side, or do they have like time restrictions, or do they talk with each other so that they are on the same page? It seems to me like if you have to be the mediator between the two sides and both of them expect you to do more than you have, then this is a little bit tough. How is it in your case?
Well, so I have like any PhD student, academic PhD student, academic supervisor that is very nice, and I really like him. So we interact a lot, and he knows the context. So so I have this on one side. On the other side, I have a company supervisor about the PhD. He doesn't follow every step of the things, but he is the person I am supposed to see if something is wrong in my PhD. And also both supervisor sometimes interact together, so if something is wrong. And there is also the at the end of every year you have I don't know, like a committee, like something like with the director of the laboratory that asks you if everything is okay, etc., etc. So you have like there is some things to ensure that things are okay, but if you are with, I guess if I was surrounded by the wrong people, it could have been very hard, because yeah, it's very fuzzy, you know. It can be, it can go very fast on the wrong side, I guess.
Yeah, yeah,
And
I understand.
I guess I'm lucky, so.
Yeah, thank you for that insight. I think Sylvia also has a question.
Yeah, more than a question is a curiosity, because I can understand that there can be some burnout related to the fact that in companies you have this very job fast piece, and sometimes you have to do many tasks, like during the day, while during a research job or PhD, postdoc, whatever, you can spend time, like spend an entire day only reading papers and stuff like that. So my curiosity, so I can see the negative impact of that, because they're so different type, kind of mental states, job states. But I was wondering if you also noticed some improvement, in the sense that it was beneficial to experience this a corporate job, to kind of also, I don't know, be more organized during your PhD, understanding better how to kind of have small tasks during the day and then setting goals, because that's something that you can learn during corporate jobs, right? So I was wondering if there was also a good side of all of this, and if you can say something about that. If there is no good side, okay, but if you can share some good
No,
experience also doing this, it would be great.
yeah, but I don't have the comparison also, because I have never been a full-time academic research student, so I don't know. But yeah, I feel like working in the company before helped me to understand how the company works, how it works, and have some nice have some nice things that help me to do my work, and also to balance the work. So yeah, but yeah, I feel like I work a lot. But topics are, I'm very fascinated by the topics, and I'm very passionate, so it's very nice. But yeah, I do really feel like I work a lot, but I guess it's part of the PhD. And yeah, as I said, I'm very happy that, because it's various, it's equilibrated, and also I feel like my company trusts me, so they allow me to manage my time as I want. I know my tasks, I know my PhD tasks. I'm not always on time on the tasks, but I know them and I do my best. So
Can I ask about, you talked a little bit about it, but I wanted to know it a little bit more concrete. How does, like, do you have examples for cross-pollination in both sides? So where the input that you, like the academic input you have from the academic side influenced like your company or like the people that work there, or how the company, the tasks that you had at the company influenced maybe the academic side, the academic people you work with?
sorry, you were asking about
The cross-pollination. So, like, do you have examples for where one of the two sides got influenced by approaches or questions by the other side?
you mean concrete examples?
Yeah, I mean, or you can be as concrete as you're allowed to by the NDAs that you sign.
I don't have anything on mine. I guess it's just like a mindset, you know. And so I just feel it. I don't know how I can describe it concretely. But there is one point maybe when you have to code. I learned a lot about coding in companies. So it really helped me to have a discipline, and to be better in code. And also I'm surrounded by very good computer scientists. so I can ask them any question when I'm coding and there is something wrong. So
Very nice. Thank you. Do you have any other questions?
I
Sorry.
have a curiosity actually. That if you started before the PhD or before your work at the company?
I'm not sure I understood, but I started to work at the company, and they were looking. I learned that they were looking for a PhD student, and at the beginning I was hesitating because, as I said, I have friends that have already experienced that, and it wasn't nice for them. They didn't finish the PhD, so it was very bad. So I was a bit hesitating, and at some point I felt like I was in a nice mood, in a nice mindset. So I went to the manager and I said, "Hey, can we talk about this PhD project?" And that's how we did it.
Okay. And your PhD is part-time or
Yeah, yeah,
nice?
three times PhD, three days PhD, 2 days work, traditional work per week.
And as a general comment, like, would you suggest other people to do it? Or
I guess it depends because I really like all my tasks, but I guess for a PhD, if the topic is very interesting, you should do it full time, because sometimes I feel a bit frustrated about that, and I also maybe feel like I'm doing half a PhD. I try
yes,
not to think like that because I think it doesn't work like that. But sometimes I feel like in the end I will only have half a PhD. I mean, not in the title, but in the amount of work. I think I'm afraid that I will be frustrated not to have been further in my work.
And do you take the same number of years that a full-time PhD would do, or do you take longer?
So, yeah, it's 3 years. So
3 years.
yeah.
And can I ask, you don't have to answer if it's too personal, but do you get salary from job and PhD then, or how is this handled in your case?
It's I'm paid from my company, and my company have a contract with the laboratory, so my company finance my PhD, they finance the laboratory, and they ask finance for research.
Okay, that is cool.
Does anybody have other question
No,
for Victor?
I just have
Because
a
it's a really
comment. I just have a comment that might be too optimistic, but it might also be that it's because you are into your PhD from 1 year and something, if I understood correctly. So hopefully it might be that later on you will be more in control of your research. So you will enjoy more, even if you have less time, at some point you would reach that plateau where you feel more confident and
Yeah, I hope so. But as we planned the PhD, we have three different steps. So it's not like one step that we want to reach slowly. It's like now the first step is done, is the work I presented you. The second step has started, and the third step will be even something else. So 3 different steps. So I don't know if I will reach any stability because it will change every time. But yeah, let's hope for it.
okay. If there are no further questions or comments, we thank Victor again.
Thank
For
you.
being with us.
Thank you.
And we see each other in 2 weeks for the next seminar.
thank you everyone. Thank
Bye
you.
bye.
Bye.
Thank you. Bye-bye.
Bye everyone.
Bye bye.
Thanks. All right.